Hello everyone, welcome to second lecture of week 7. In this lecture, we will explore Cauchy mean value theorem. In the last lecture, as you can see that we have explored Lagrange mean value theorem. Here we will going to extend that version in a Cauchy mean value theorem, and then we will give some examples, and then we testify or verify this Lagrange mean value theorem through those examples. So, what are the statement? So, it is also called general mean value theorem. We call it the general case for a Cauchy mean value theorem. And a statement, now the statement is quite different than the Lagrange mean value theorem. In the Lagrange mean value theorem, there will be one function which is continuous and differentiable. But here in a Cauchy mean value theorem, we are considering two functions fx and gx. So, let fx and gx be two real valued functions defined in a closed interval a to b, such that fx and gx are continuous in that closed interval a b, and both functions are differentiable in open interval a b. So, f and g are continuous in a closed interval a b, and here differentiable, both functions are differentiable in open interval a b, and this was the first one, this one was the second one, and the third one, consider g dash is not equal to 0 for sum of x lying between a to b, for sum, right. Then there exists a point C from lying between a to b such that if b minus fa divided by gb minus ga is equal to f dash of c divided by g dash of c. So, now we are looking for the ratio of the slope of the two functions at the same point C. So, C is the point, and the ratio of the slope of that curve at that point f dash of c and g dash of c, we are looking to evaluate those ratio, and that ratio is nothing but it is the ratio of the difference of the end points value of f and g. So, fb minus fa divided by gb minus ga can be calculated or can be manipulated as f dash of c divided by g dash of c. How to prove that one? We are going to prove by constructing a function as we have constructed in proving the Lagrange mean value theorem, and then we will prove in a very similar way. So, let us construct a function phi x such that fx plus a into gx. In the previous Lagrange theorem, we had used a into x only, but here we are going to use a into gx. Now, this phi x function, look at closely, a for continuous function, differentiable function, a is a constant one, g is continuous function as well as differentiable function, a is the constant one, a is the constant one. So, now phi of x also simply become is a continuous function as well as differentiable function, continuous in a closed interval a b and differentiable in an open interval a b, right. Why? Using the algebra of the continuity as well as algebra of the differentiability, where we have seen that sum of the two continuous function is continuous and sum of the two differentiable function is differentiable. Now, choose a such that phi a equal to phi b. Calculate this phi a and phi b first. So, phi a is equal to f of a plus a into g of a, using the our assumptions, right. And phi of b is equal to f of b plus of a into g of b. Now, calculate phi of b minus of phi of a. So, this is equal to f of b minus f of a and plus a into g of b minus g of a, right, clearly. And we knew that phi a and phi b is equal to phi a and phi b are equal here. So, the difference between phi a and phi b is going to be what? 0. So, this will give you A is equal to phi of B minus f of B minus f of A divided by G of B minus G of A, right. So, minus, that is the minus one, right, here, because this will phi A phi B and this one is minus, so this will be minus 1, right. So, this means we had this theorem for A. Now, the function become continuous in a closed interval, differentiable in an open interval, and with the choice of the selection of A, phi A is equal to phi B. This is the Rawls theorem. This is the Rawls theorem. So, since it fulfills the all three conditions of the Rawls theorem, so by the Rawls theorem we knew that phi of C is going to be 0 for some point C lying between A and B. So, using the same thing, we have here there exists some point C such that phi dash of C is going to be 0. Use the same thing here. So, phi dash of X is going to be 0 somewhere. Phi dash of C is going to be 0 somewhere here. So, this will give you, okay, let me do from here itself. So, phi dash of C is equal to f dash of C plus A into G dash of C, right, and this is going to be 0, this is going to be 0. So, this is equal to f dash of C plus A into G dash of C. So, A can be written as minus f dash of C divided by G dash of C. So, now compare these two itself, this will give you f dash of C, G dash of C is equal to minus A, that is equal to FB minus FA divided by GB minus GA. So, that means the difference between the end points FA and FB and similarly GA and GB leads to the ratio between their slopes at some point. That is the Cauchy mean value theorem. We will have the another statement for the Cauchy mean value theorem, as we had hinted out or gave you a hint about there may be some statement including theta and h. So, here we have we are going to give you the statement in a detail here. So, alternative form of the Cauchy mean value theorem, Cauchy mean value theorem. So, fx and gx be two real valued functions defined in a closed interval AB such that fx and gx are continuous in a closed interval AB, and fx and gx are both differentiable in an open interval AB, and g dash is not equal to 0 for some value lying in open interval AB. Then there exists at least one theta, remember this one, and what will be the theta value? Theta must lying which is less than 1 and greater than 0. So, theta lying between 0 to 1 such that f of A plus h minus fa divided by ga plus h minus ga equal to f dash of A plus theta h divided by g dash of A plus theta h, where theta lying between 0 to 1. So, that is the alternative form of Cauchy mean value theorem. Could you relate yourself about the Lagrange mean value theorem in theta respect? So, that will give you f of A plus of h minus f of A is equal to f dash of A plus theta h. So, that is the Lagrange mean value theorem. So, that what we had in the previous lecture. So, this is the Lagrange mean value theorem, and you can easily prove as we are going to prove this one, right. So, without looking for the proof, because the proof is quite simple, proof is on the similar line as here. So, you have to construct one function such that that function become a continuous function as well as differentiable function containing some constant A, and the two functions, right, fx and gx, and then using the Rawls theorem, that will give you f dash of c is equal to 0, put those value and you will get the answer, you will get your proof, right. Doing the same thing, it will the proof is quite easy. So, I am leaving the proof here for both of you, and then we will give the geometrical meaning of the Cauchy mean value theorem. The Cauchy mean value theorem has geometrical interpretations given two differentiable function fx and gx here. So there are two differentiable function fx as well as gx on an interval ab, closed interval ab. There exists a point c. There exists a point c within that interval where the slope of the tangent to the stressed curve fx and gx is equal to the slope of the second line connecting the points FAGA, FBGB. So here is the point C. Here is the point C here. This is the point C here, for which it is connecting. It is equal to the slope of the second line, and FA and GA is here. This is the point of FA and GA, and this is the point of FB and GB. And G dash of X is not going to be 0, right? So as you can see here, in that statement, G dash of X is not going to be 0, right? So that will makes you the point, there exists a point C such that it is, there exists a point C within that interval AB where the slope of the tangent to the stressed curve fx gx is equal to the slope of the second line connecting that point, this one. So this is the connecting that point FA and GA, and the slope is quite equal to this slope, the second line of this one. That means it is the parallel to that lines. So the chord FA, GB, FA, GA, FB, GB is parallel to the tangent of that line, right? So what are the interpretation? Useful generalization of the law of mean value theorem by considering a smooth curve in parametric representation x equal to gt and y equal to ft. Now since we are always using fx and gx2 functions, let use in a parametric form. So let x is given as a gt and y is given as ft. T is a parameter here, and t lying between where to where? A to b, right? A to b. The slope of the tangent to the curve at t, at the point t, is equal to c is f dash of c divided by g dash of c, and this is equal to what? We had already calculated fb minus of fa divided by g of b minus of g of a, right? The generalized law of mean value theorem asserts that there is always a value of c in AB such that which the slope of the curve is equal to the slope of the tangent at c. So that is what in a parametric form we interpret it, and by examples it will be very clear that how the interpretations will useful for you. So these are the interpretation, you remember this one. So using Cauchy mean value theorem, find the value of c for the function fx, which is given x square plus of 2x plus 2, and gx s square minus x plus 25 on an interval closed interval 1 2, right? So there are two functions are given, fx and gx. One interval 1 and 2 is given. Then we have to verify the Cauchy mean value theorem, and by the Cauchy mean value theorem we have to find the point c for the function this, right? So since fx and gs are polynomial functions, fx and gs are continuous in a closed interval. So f of x is given as x square plus of 2x plus 2. So this is a continuous function. So f dash of x can be calculated, that is 2x plus 2. G of x is equal to x square minus x plus 25. So g dash of x can be calculated 2x minus 1, right? And here f dash is calculated, g dash is calculated. That means both functions are differentiable as well in 1 2. Now f dash is given, g dash is given, and can we check that g dash of x is not equal to 0 for x belongs to 1 2? Let's say g dash of 1, that is equal to 2 minus 1 equal to 1, which is not equal to 0. g dash of 2 equal to 4 minus 1 equal to 3. Both are of the same sign, therefore there is no a point. So that means from 1 to 2 g dash of x is not going to be 0. That's the validation of the this one. But now here it's calculating all these possible values. So we have calculated fb as 10, f of a is equal to 5, g of b equal to 27 and g of a equal to 25. We have calculated here. Now f dash of c divided by g dash of c can be calculated as f of b minus f of a divided by g dash of gb minus g of a. So this is equal to 10 minus of 5 divided by 27 minus 25. This is 5 by 2. So this is the ratio. F dash of c and g dash of c has the ratio 5 by 2, right? Now I can calculate from this one. What will be the f dash of c? F dash of c equal to 2x plus 2 to 2c plus 2. So I can write this one, f dash of c equal to 2c by 2 and g dash of c equal to 2c minus 1. So 2c plus 2 divided by 2c minus 1 is equal to 5 by 2, right? From here. Now solve this one. So this is 4c plus of 4 equal to 10c minus of 5. And take this c here somewhere. So 4 plus 5 is equal to 10. C minus of 4c equal to 6 of c. So c equal to 9 by 6 equal to 3 by 2. And now you can check that c equal to 3 by 2 lying between where? Lying between 1 and 2, the given interval. So here is the 3 by 2. So for which f dash of c is equal to g dash of c is equal to 5 by 2, which is equal to fb minus fa divided by gb minus of gc. So by using the Cauchy mean value theorem, I had identified the point c between 1 and 2 such that f dash of c divided by g dash of c is equal to the ratio between the differences of the endpoints of two functions, that is fb minus fa divided by gb minus gm. Here, so we have calculated c equal to 3 by 2. Now this will be the last problem, and I believe that these problems enhance your understanding for this Cauchy mean value theorem. Find the value of g2. Here the problem is in the different sense. It says that find the value of g2 if the function fx is differentiable and gx is not equal to 0. Obviously, one function is given and we need to prove the other function such that f2 equal to 14, f3 equal to 20, fx equal to 12 into gx and g3 equal to 6. It is given and now we have to prove this one. Since g dash of x, isn't it, is not equal to 0 and fx is differentiable, that means we can use the Cauchy mean value theorem. So by using the Cauchy mean value theorem, we knew that f dash of c divided by g dash of c is equal to f of b minus of f of a divided by g of b minus of g of a, right? So firstly, we have to put all those value right hand side. What will be the fb? fb is given. fb is given here 3. So I am considering 2 and 3 as a interval. So fb is 3. So this is 20 minus f of a equal to 14 divided gb. gb is given g3 equal to 6 minus 12 into g of x here, right? So that is equal to z2. This is equal to g2, right? And this is equal to f dash of c. f dash of c is equal to how much? f dash of c divided by g dash of c, right? So what will be the value of f dash of c? Here it is given fx equal to 12 of gx. So f dash of x is equal to 12 into g dash of x. Therefore, f dash of c is equal to 12 into g dash of c. So I can write this one as 12 of g dash of c divided by g dash of c is equal to the same number 20 minus 14 is equal to 6 divided by 6 minus g of 2. And since g dash of c is not equal to 0 here, so we can cancel it out, and we can just simplify the expression. So this will give you 12 into 6 minus of g2 is equal to 6. So this will give you how much? 72 minus of 12 of g of 2 is equal to 6. So 12 of g of 2 is equal to 72 minus 6 is equal to how much? 66, right? So g of 2 equal to 66 by 12 is equal to 22 by, this is 4, so this is going to be 11, right? And this is going to be 2, so 11 by 2, right? So that's what the answer is. This is going to be 11 by 2. This is what we had find out here. So we had find the value of g2 such that g of 2 that is 11 by 2 such that these criteria fulfill, right? So I think I will do it once again for all these. Okay, so here is the problem. Find the value of g2 and when fx is differentiable and g dash of x is not equal to 0 such that f2 is given, f3 is given. With these two value, you have to understand that these are the end points for the function. So we have end points 2 and 3. These are our closed interval AB, and for which fx is given. Fx is a function of gx, 12 into gx, and the g3 is given. G3 is given as a 6. So here f3 is given as 20, g3 is given as 6. Here f of a is given as 14, and g of a I have to calculate. But one of the relationship is given, f of x equal to 12 into gx, and g dash of x is not equal to 0. That is given. So to use this one to find out the value of GA, that is equal to G2, you need to use Cauchy mean value theorem. And Cauchy mean value theorem will give you the idea that how the ratio between the slopes of the two function is connected each other. Since the function itself is connected fx equal to 12gx, and fx is a continuous and differentiable function, that means we have some idea about Cauchy mean value theorem. Use the Cauchy mean value theorem. Cauchy mean value theorem is what? fb minus fa divided by gb minus ga, that is equal to f dash of c divided by g of x. Calculate this one. This is going to be 12 into g dash of c divided by g dash of c. So this will be cancelled out due to the g dash of c is not equal to 0. So this will be how much value? That is 12. And put all those values here. You will get 6 divided by 6 minus of g of 2 equal to 12. So that will be 6 is equal to 72 minus of 12 of g2. Therefore 12 of g2 is equal to how much? This is 72 minus 6 equal to 66, and therefore g2 g of 2 equal to 66 by 12, and this will be cancel out, and this is for 3 22 and this is 4, so this is 11 and this is 2, right? So this is 11 by 2, and that is your answer, 5.5, right? So answer is 5.5. So I believe that these Cauchy mean value theorem and their uses to solve some of the examples or some of the problems will enhance your concepts, and we will more problems in the next lectures we will explore with using those Cauchy mean value theorem as well as the Lagrange mean value theorem. So thank you so much.